second grade. Yesterday, you can see behind me, we were subtracting tens and 100s from a 3-digit number. We're going to continue subtracting from 3-digit numbers today, but our work today will be a little different. Let's go ahead and take a look at our learning target, and then we will get started with some problems to do together. I can subtract a 2-digit number from a 3-digit number using place value. So what am I asking us to think about today? I'm asking us to think about taking a 2-digit number from a 3-digit number, but I really want us to focus on that place value. In other words, how much are those numbers in those places worth? And how will that make it easier to subtract? Let's take a peek at our first problem today and think about how we're going to solve it. You can see that it is a story problem. So one thing I'm going to ask us to do after we read it together is I'm going to ask you all to help me figure out what we know from the story and what we're trying to find out so that we can write an equation to match it and then we can solve from there. Let's take a peek. There are 136 students in second grade at Miles Davis Elementary. 24 of them brought their lunch to school. The rest buy school lunch. How many second grade students are buying their lunch? Let's see that one more time. There are 136 students in second grade at Miles Davis Elementary. 24 of them brought their lunch to school. The rest buy their school lunch. How many second grade students are buying their lunch? What do we already know? Yes, we already know that there are 136 students in second grade. That's a lot of second grade students. Holy guacamole. What else do we already know? 24 of them bring their lunch. That means that they pack their lunch. What else do we know? That's right. We know that the rest of them buy their school lunch. So 24 of them bring their lunch. The rest are buying their lunch when they get to school. What are we trying to find out? That's right. We want to find out how many is the rest, right? How many second grade students are buying their lunch? So what would an equation be that might help me figure that out? What's an equation that might help me figure that out? Go ahead and write it in your math notebooks. Tell me about these numbers in this equation. What does that represent? And that one? Why are you subtracting? To help you find that unknown. Okay, friends, let's go ahead and share that. 136 minus 24 equals box. Okay, how does that help us find this unknown? Right, we have 136 second graders. What does the 24 represent? The ones that bring lunch. What is this number going to be then? Right, how many students buy their lunch? Now we're going to work on subtracting today, but I saw somebody write an addition sentence that would match this story. What would that look like if we were writing an addition sentence to match this story? 24 plus box equals 136. How does that help us solve this problem? Yes, so part of the kids are bringing their lunch. Part of them are buying their lunch. Buy. What does that 136 represent? Yes, those are the second graders. So some buy, some bring, but there's 136 kids total that are eating that lunch. Very good. Now, go ahead and see if you can find that unknown. What would go in that box? Should be the same, right? So what would go in that box? And show me how you might subtract this. You're going to use any kind of model you might like. So you might use base 10, you might use a number line, you might do something else. Go ahead and solve it how you think, or what works best for you. Where is your 136 in your model? What about your 24? What did you do first? I see you base 10 blocks. What did you do first with your base 10 blocks? Why did you take away your 10s first? Then what did you do? And how did you know there was 2 left over? Okay. So what would go in that unknown? You used the number line. What did you do? But you didn't subtract. Why didn't you subtract? So when you started, where did you start? You started on that 24. And so what jumps did you make? You made a big jump of 100. Why 100? Okay, because you're trying to get to 136. Friends, if you're solving at home, I want you to stop, pause me, because if you're not done, I want you to make sure you have time to finish up. And then when you're ready to listen, I want you to go ahead and unpause me, and then you can listen to this work with us, okay? But for right now, pause us if you're not done, because we're going to share some really great strategies. Talk to me about what you do with your base 10 blocks. When you drew this, what number were you representing? And how did you know what to put where? Okay, so there's a 1 in the hundreds, 3 in the tens, 6 in the ones. And then what did you do? Why did you take away 2 tens? Because there's 2 tens and 24. And then what did you do? All right, when you took away 4 ones, what did you find out? You had 100, you had 10 in your tens, and you had 2 ones. And what number did that make you? Did that show? 112. 100 and then a 10 and 2 ones is 12. What did you do with your number line? Where did you start your 136? Why did you start it down here? Okay, because you're going to smaller numbers. All right, and so your bigger number is going to go here. So what did you do first? Why did you make 2 jumps of 10? Remember our work from yesterday, so that 10 space is going to change. And what did it change to when you took away 10 from 136? What about when you took away 10 more? Okay, and then what did you do? Okay, when you took away 4, what did you land on? How did you know it was going to be 112? Because 6 take away 4 equals 2. So where's your 136 in this model? Where you started, okay, and then where's your 24? 10, 20, 24. And where's the answer to your problem? What does that number 112 represent? The number of students that are buying their lunch. What do you notice about these 2 strategies, friends? They both started with 136. This is where they start on the number line. They drew 100, 3 tens, and 6 ones. What else do you notice? They took away 2 tens. They took away 4 ones. All right. So now let's show some other ways, because I saw some other friends doing something very different. Okay. Talk to me about what you did with your number line. It looks a little different than this number line. Where did you start? Why did you start at 24? Okay, so you knew that 24 kids were bringing their lunch. And what did you do first? Made a big jump of 100. Why 100? Because 100 plus 24 is 124. And what number are you trying to get to? The total number of second graders. Gotcha. So what are you going to do next? Why just the jump of 10? Because it gets you to 134. All right. And then you need to do 2 more to get to 136. So where's your 24 in your work? Where you're starting, okay? Where's your 36? Where you're stopping. So where's the kids that are buying their lunch? Where's that represented? And how do you know that that makes sense? There's 100, 110, 112. And then we'll circle that. Okay? All right, so there's 24 kids that have their lunch, 112 that are buying their lunch, and then there's 136 altogether. So if you add the kids who brought and the kids who buy and you put them together, you have all your second grade students. Wonderful thinking. One more thing I want to share that some friends were doing, and I want to make sure I share this because I think that if we can show these different ways with this problem, it can help us solve the next couple that we have in store for us today. But you didn't use a picture. You didn't use base 10. You didn't use a number line. What did you do? Okay, so you did 136, and then what did you do? You took away 24. And so what did you find when you laid it out like this? 100 take away 100 is 100, okay. 30 take away 20 is, how did you know it was going to be 10? Because 3 take away 2 is 1, so 3 tens take away 2 tens is 1 10. Okay, and then you have 6 take away 4, which is 2, which is 112. Okay, so take a minute, second grade, and just peek at these strategies, these ways of solving this work. What do you notice about them? Where do you see this work in another one of the models? You see it over here, and how does that connect? There's that 100, the 30, and the 6. Okay, so what else do you notice about that? Your hundreds didn't change. You didn't take away any hundreds, but you did take away 2 tens. You did take away 4 ones. And you had 2 left, two ones left, 1 10 left, and you still have that 100 left. So as we look at this and look at these ways, I want us to put these in our minds as we solve the next couple. So what numbers can I go right here? 112, and we can see that with that work. So if we're subtracting, we actually can add 2 if that makes it a little bit easier for you to do. All right, our next problem, we're going to use a model again. But remember, that model could be anything. A model is a way to show our thinking. 157 take away 36. 157 take away 36. Go ahead and show me how you might solve this. You're using your base 10. And tell me what you did with your base 10. How many hundreds are you going to have? How does that show 157? Okay, and what are you going to do next? How do you show that you're taking away 36 on your number line? And why are you making jumps of 10 and then jumps of 1? And what do you notice about that 10's place and that 1's place when you're taking away? What place doesn't change? Why doesn't your hundreds place change at all? You're not taking away any hundreds, are you? All right. Ooh, I like that. Go ahead, friends. We're going to come together in 5, 4, 3, 2, 1, and done. Let's start off with those base 10s. How many of you needed those base 10s to help you show this thinking? I noticed that a lot of my friends, some of them are still using the actual blocks, but a lot of you are just drawing it to have that visual. So when you draw it, what does that look like? 100, 10, 20, 30, 40, 50, and then 7 ones, okay? And when you draw 100, 50, and 7, what are you going to do next? Why are you taking away 3 tens? Okay, so in 36 there are 3 tens. Then what are you going to do? Take away those 6 ones. And what do you notice? You have 100, 2 tens, and 1 1 left. And so what does that number equal? What does that show? 121. I'm seeing some wiggle waggles, but not everybody solved it that same way, did they? How did you solve it? And where did you start on your number line? With what number? All right, and if you started when you started with 157, what did you do first to solve this? Okay, so you take away 30. Why one big jump of 30? Okay, so what place changed? So your hundreds stay the same. 5 take away, 5 take away 3 equals 2. So 50 take away 30 equals 20, okay? And then your ones place stayed the same. That reminds you of that work we did yesterday, right? Absolutely. So you're thinking in your head, I know 5 tens, take away 3 tens is 2 tens. So you can solve 157, take away 30 right up here, right? Then what are you going to do? When you take away 6, what do you find? Okay, your hundreds place stayed the same. Your tens place stayed the same. And you said 7 take away 6 equals 1. So where's your 157 in your work? Where you're starting, right? Where's your 36? And then where's the answer to that problem? Where's the unknown? Where you're landing. All right, I've got one more to share, and then I want us all to take a minute and talk about how they're similar and how they're different. What did you do with your partial sums, or with your partial differences, I guess? And where do we else see 157? 150 and then 7. All right, we see that right here. 150 and then 7. What did you do next? Put a minus sign, and what did you minus? 30 and 6. And why do we have those plus signs in there? Because if we're subtracting, why are we putting a plus sign? Right, so we're looking at this. 157 is 100 plus 50 plus 7. 36 is 30 plus 6. But when we start working up and down, we're using this symbol or this minus sign to help us know what we're supposed to do with our work. So we're saying what? 7 take away 6. You're going to take your ones from your ones. 7 take away 6 is 1. You're going to add your tens and your ones and your hundreds together. 50 take away 30 is. And then your hundreds stays the same. So now our answer is going to be our hundreds plus our tens plus our ones. And what does that show us? 121. Very good. So now take a minute and look at each of these ways. What do you notice about them? They all have the same answer. I think that's something that we say every time, isn't it? What else do you notice about it? I noticed that too. Everybody took away 3 tens, 3 tens, 3 tens. We all took away 6 ones. Absolutely. So how do decomposing these numbers help us solve these? Yeah, it'd be a lot if we were going to just make a bunch of jumps of 1, right? So when we're doing this, we're chunking it up, or we're decomposing our numbers into tens, ones, and hundreds, and we're making that more manageable. Our ones from our ones, our tens from our tens. Then we didn't have to take away any hundreds, but we did the same thing here, and even the same thing here. Biting out smaller chunks makes it easier to solve. We're going to do one more together, and then you're going to do this one for your exit ticket. Ready? 241, take away 25. Ooh. Show me how you're going to solve this. Friends at home, pause me now, because I'm not going to give you think time this time, okay? I'm going to give you a few things to think about, and I'm going to ask you to pause so that you can work and then resume me when you're ready. Where is your 241 in your model, whichever model you choose? What do you do if you don't have enough ones? How did you show that in your model? I want you to be thinking about that as you're solving. Now go ahead and pause me and resume me when you're ready. All right, friends, what do we notice about this work? What did you do? 241, okay? And then what did you do? Why couldn't you take away 5 ones? Because you only had 1 1. So what did you have to do to help you with that? Cross off a 10, and you needed to draw 10 more dots for the ones, right? So you're just replacing it. Do you still have 241? 200, 210, 220, 230, 240. Let's make sure. 231, 232, 233, 234, 235, 236, 237, 238, 239, 240, and then we have 241. I say that, friends, because I have second graders in my class that when they go to make a 10, they're using this one that's already there to help them get to that 10, right? So instead of having 11 ones now, they actually only had 10 ones and they didn't have 241 anymore. Does that ever happen to you? You're making a 10, but you're using one of the ones that's already there to help you make that 10. So you do want to make sure that if you cross off one of these 10s, that you're drawing 10 ones to replace it, right? You're just taking that 10, you're breaking it apart into smaller parts, into ones. Then what did you do? Sorry, it was a little side jaunt. You took away 5 ones. 1, 2, 3, 4, 5. And what did you do with your 10s? 1 10, 2 10s. And why am I crossing off 2 more than the one that was already crossed off? Because this one was not taking away, right? It was just being traded. So you're taking away those 2 10s and those 5 1s. And then what did you find? Still had 200. You have 1 10 and 6 1s, which makes what number? Okay, so you know 10 and 6 is 16, and 200 is 216. Ooh, can I have somebody share that with their base 10 or with their number line? Because I think that would be really valuable to see how we can regroup, right? So when we took this 10 and we broke it up into those 10 ones, the name for that is regrouping, or we know that that prefix re means again, so you're grouping it again. So when we regroup with our numbers, we have to show that we're trading it out, right? For something that equals the same amount. We're trading a 10 for 10 ones. So how does it look on the number line? All right, when you started with 241, what did you do first? You took away 20, okay? So they took the ones away first, and you took the 10s away first. And what did you find when you took away 20 from 241? And how did you know you have 221? Because your 10s place is the only place that's changing, and 4 take away 2 is 2. All right, and then what did you do? All right, so you took away 1, which was 220. Why did you just take away 1? 10 is a friend, ooh, ooh, ooh. 10 is a friend, ooh, ooh, ooh. That's right. When we're trying to get to that 10, it makes it so much easier to solve. And then what did you do? All right, so you need to take away 4 more. How did you know that you needed to take away 4 more? Because you're taking away 5 total, right? So you're taking away 1, and then 4 makes 5. And then where did you land? If you were at 220 and you took away 4, 216. Because 10 take away 4 is 6, so 20 take away 4 is 16. So 220 take away 4 is 216. So where's your 220? Where's your 241 in your work? Where you're starting? Where's your 25 that you're taking away? 20, 21, 4 more is 25. And then where is your unknown? 216. So we saw our regrouping with our 10 and the 10 ones there Where is that regrouping when we're using our number line? Where they're jumping to the 10 and then they're going 4 more, right? Yes. So it's like there's that 10 and there's that 4 more. Do you see that in the work? That's that one that got away, and then there's the 4 extras that you have to take away from that 10. Yeah, so that's that regrouping when we start looking at that number line. We can do it either way. We can do it more ways than that even, but there's that piece of regrouping. So we didn't have to regroup here. You have to regroup on this one. And I'm not sure, but I'm going to guess you're going to have to regroup on your exit ticket. So what I'm going to have you do is in your notebook, before you do your independent practice, I want you to write this equation. 344 take away 27 equals blank. And I want you to show me how you're solving that with your models and your equation. And I can't wait to see it tomorrow. Talk to you later. Good luck and happy solving.